Alright, so this video is an overview of the code for our term project. So I've included a README file. So this has instructions, so make sure to include an asterisk every time you multiply. Note that the program will still run if you don't use it, but the results will not be accurate, so please just make sure to use it. Pi and E, you actually have to write it out. Please use these decimal approximations. I guess you can use as many as you like, but that should be sufficient. E to the x should be written as POW 2.71828, comma x. Here's some other operations that are supported. Not everything is. So if you want to write square root, this is how you do it. Likewise, if you want to write arc cosine of x, this is how you would do so right here. Log is supported, but natural log is not, so sorry about that, but take what we can get with our parsing package. So this is just some instructions about how the program will run, but you can see that if you watch the YouTube videos that I've provided. There's 5 examples. If you follow this link, it's a playlist that I've created. So if you go over here to the driver, you start off with a string, evaluate at function. So this function takes in a user-defined function and a point, and it evaluates that user-defined function at that point and returns the string representation of it. If you see down here, we have some weird stuff going on. That's because JEval, the parsing package I'm using, likes to stick an E inside of the string, but strangely, it doesn't know how to handle it. So the E is like if you were to write 4 times 10 to the negative 12, it would be written as 4E negative 12. If you try and fix it by just writing it as 4 times POW 10 negative 12, it just slaps an E back in there. So this while loop builds the string in the proper format by using an array list that splits the string upon the E. And then we have a while loop to add the proper amount of zeros, and yeah. So we return it either here or here, depending on if we needed to fix the string. And so here's the bisection method. A scanner is what we use to take in user input. So we will be prompted to enter your function f of x, then it kind of verifies that yes, this really is the function that you entered. Then enter how many iterations of the bisection method you'd like, enter your point A, so this is the leftmost point, your point B, the rightmost point, and then we have a variable called f of A, and this is your function evaluated at point A, and you have f of B, which is likewise your function evaluated at point B. So we check, hey, is there actually a root? If f of A times f of B isn't greater than or equal to 0, well then you have to try again. And then, or just kidding, if it is greater than or equal to 0, you have to try again. Because you had a poor choice of A and B, then you get down into the rest of the code. So this point C is the midpoint of A and B. And then f of C is the function evaluated at point C. And so it just carries on with the bisection method, and then we have Newton's method down here. So once again, you enter your function, the derivative, we're having the user do this because it's quite difficult to derive it on the computer with the program that we have. Then how many iterations, and your x0 value, we have this list, it's an array called xn's, and this holds the x sub n's that we get from performing iterations of the Newton's method. So you have string, numerator, and denominator, because you have like xn minus f of xn divided by f prime of xn equals xn plus 1. So the numerator is f of xn, and the denominator is f prime of xn. So sometimes you end up dividing by 0 because the denominator is very, very likely that the derivative evaluated at a point could be 0. So in that case, we'll print out dividing by 0, and Newton's method cannot continue. And then we bump up k to be greater than n, so we will not continue the loop anymore. And then otherwise, all is well, and we continue on with the Newton's method. And then down here we have secant method, and we have you enter the function, the iterations, point x0, x1, given by the user. And so we enter those. Again, we have an x sub n list, which is defined up here. And then we set the first thing in the list to x0, the second thing to x1, and then xi minus 1 is just like x sub I minus 1, and f of xi minus 1 is the function f evaluated at x sub I minus 1. And you have the numerator and the denominator, which is, the numerator is right here, so this is basically xn I minus 1 minus xn I minus 2, and then down here is the f of x I minus 1 minus f of xi minus 2. So once again, the denominator could be 0, and then it'll print out saying dividing by 0 cannot proceed, and we bump I up to being greater than n, so we will never continue the loop ever again. Then here you continue on like all is dandy, and then this is our main function. So we have a set called methods, and these are the only 3 acceptable things to enter that the user can enter. So we have a scanner, so this is what will prompt the user to do, and if the thing that they enter is not in this set called methods, they have to keep trying over and over again. And then whichever one they select will call the 3 methods that I showed above, and that is the program. Thanks for watching.